So you do this regularly every day?
No, not the, I've done it once before. And,
Stunning.
it's
Like
India, the emerging power in defense manufacturing, empowering our armed forces in the high mountains, fighting battles in the harsh terrain of deserts, and securing India's vast coastline. The Indian defense industry is marching ahead with strength and power, continuously engraving the success story of Make in India. A well-developed ecosystem has created indigenous capabilities in naval systems, aerosystems, missile, electronics and land systems, keeping pace with the global trends in war-fighting technologies. Greater emphasis on self-reliance, increased participation of the Indian industry with startups, MSMEs, ordnance factories and PSUs as partners. A robust defense and aerospace industry base has been created by simplification of procedures, new policy for indigenization, innovations for defense excellence, offering government test facilities and proof ranges to industry, dedicated team to facilitate the private industry, encouraging intellectual property culture in defense, defense corridors in Uttar Pradesh and Tamil Nadu, reforms in offset policy. Such initiatives have strengthened the ecosystem and defense manufacturing base of the country, resulting in growing investments, production and exports. And the journey of excellence continues. After the remarkable success of DefExpo 18, Ministry of Defence is ready to showcase the digital transformation of defence at Lucknow, a vibrant manufacturing hub of Uttar Pradesh, focusing on innovation and emerging technologies, bringing in a paradigm shift from conventional to futuristic technologies. A show of India's renewed and strengthened defense and aerospace industry, showing alongside the experience of global defense manufacturers. Come, experience the power of growth and commitment. DefExpo 2020. Explore the world of opportunities.
Hello, good afternoon, namaste. A very warm welcome in this new year 2020 to yet another webinar from NEGT Digital India and Ministry of Defence. My name is Bhumika and I welcome you all on behalf of National E-Governance Division Elements team. I will be taking you through the various steps of this fourth webinar for Defence Expo 2020. These webinars are a collaborative effort of Department of Defence Production, Ministry of Defence and NEGT Digital India Elements team, Ministry of Electronics and IT. As India is emerging as a defense manufacturing hub, this edition of DefExpo is focused on digital transformation in aerospace and defense sector. DefExpo 2020 will bring the leading technologies in defense sector under one roof and provide a myriad of opportunities for government, private manufacturers and startups. The event is scheduled from 5th to 8th February 2020 at Lucknow, India. As we proceed, you will get to hear a lot from our eminent speakers. Today, it is my honor to begin with this session by introducing Professor Krishnaswamy VijayRaghavan. He is the Principal Scientific Advisor to the Government of India. He was conferred the honor of Padma Shri in 2013 and is joining us from NEGT Studios here at New Delhi. He would speak on the topic data, design, and defense-related industries. Also joining us is Brigadier Suresh from Department of Defense Production from NEGT Studio here at New Delhi. He would give us an overview of the topic and a detailed introduction of our eminent speaker. Before I hand over, I will take you through certain housekeeping. As you see on your screen right now, this webinar is scheduled for approximately 40 minutes and will conclude at around 3:40 Indian Standard Time. Microphones and cameras, I request all the panelists are requested to disable their microphones and cameras when not in use. There is a chat option on your screen. If you have any concerns regarding the audio video settings, please let us know through this chat option. There is a Q&A section on your screen. If you have any questions for the webinar speaker, please post your questions in the Q&A section. The best question would be awarded and will be notified in the next webinar. For the last webinar, Mr. Jawar Singh from IIT Patna is the winner for the webinar held on 20th December 2019. There is a poll at the end. I would request everyone to please rate us in the poll on the quality of the webinar. There is also live YouTube streaming happening on the Digital India YouTube Learning channel. We'll notify the link shortly. With this, I now hand over to Brigadier Suresh to introduce our topic and our speaker for today. Over to you, sir.
Good afternoon, everybody. Today, I take this opportunity to welcome Professor K. VijayRaghavan. He is the Principal Scientific Advisor to the Government of India and Chairperson of Prime Minister's Science, Technology and Innovation Advisory Council. He was Secretary, Defense Department of Biotechnology, Government of India from January 13 to February 2019. The Principal Scientific Advisor works in all arms of the government with states, citizens, national and international agencies. The goal is that the benefit of science and technology and innovation solutions reach the most needy for the sustainable development of India and for the well-being of our planet. Dr. VijayRaghavan is also a distinguished professor at National Center of Biological Sciences, Tata Institute of Fundamental Research, Bangalore, and was the NCBS director till 2013. He studied chemical engineering at Indian Institute of Technology, Kanpur. Holds a PhD in molecular biology from Tata Institute of Fundamental Research. Was a senior research fellow at the California Institute of Technology. His research is on nerves and muscles and how complex behavior emerges during animal development. Dr. VijayRaghavan is a fellow of Indian Science Academy and Royal Society, the Academy of Medical Sciences, UK, and a foreign associate of the US National Academy of Sciences. He was awarded the Padma Shri by the Government of India in 2013. The topic which he will enlighten is data, design, and defense-related industries. Over to Professor VijayRaghavan.
Thank you very much, Brigadier Suresh, and thank you, Bhumika. It's a great pleasure and an honor to be here today to talk about data, design, and defense-related industries. You already saw in the video before we started about what defense industries are about. And one interesting feature of that video was that it focused substantially on what you can see, feel, touch, and hear, basically hardware and its capabilities. What I would like to add on to that layer today is about the dramatically changing situation in defense and in other aspects of our society, of how onto this layer today, the influence of data is coming about in extraordinary ways. This has already been articulated by many in multiple different contexts, but I think there is some extraordinary opportunity for industries in India, for engineers, small-scale industry, large industries, and industries all over the world to collaborate, bringing data into decision-making and to equipment in a variety of ways. But there's also a lot of misconception about what data and its consequences, i.e. artificial intelligence and machine learning can do. So what I will do very briefly is to summarize the opportunities and the perils of dealing with data in the broad context of of our society and defense in particular. Now, let us look at specifically areas such as defense. And what does it involve? It involves the sensing of information, the gathering of that information, and processing it in some manner, and feeding that back into a decision. And that decision could be in an aircraft, it could be a defensive mechanism, it could be an offensive mechanism, and so on and so forth. But this essence of sensing, processing, and action is common to everything else we do, and indeed is common to us as animals on this planet. So let's go through what this means in today's world. Now let's briefly imagine a future, let's say 20, 30, 40, 50 years ago, and see how we would stand in that data-driven future. You can imagine a situation where the collection and analysis and use of data is so pervasive that this machine learning AI algorithm can tell individuals what is best for them, can tell countries, organizations what is best for them, merely, quote unquote, by analyzing data. And therefore, the need for human intervention in decision making, some people argue, is going to be less and less, and data is going to be the key. If this were true, even if not completely true, if it were reasonably true, then this will result in an extreme asymmetry in that those who have the ability to collect, analyze, and act on data have knowledge and power, and those who don't have the ability to collect, analyze, and act on data don't have knowledge and therefore don't have power. And this asymmetry will only keep widening. And this is not true just of defense. This is likely to be true if this scenario is correct. And we don't know whether it will be correct. If this scenario is correct, this is likely to be true of every different area. So what is then the future of this so-called artificial intelligence? So large corporations do this all the time, and governments also do this a lot. The corporations do it for commercial purposes. And it's important to keep in mind that this kind of a knowledge, whether it's like corporations or government or defense ministries or societal organizations, all of them are really converting knowledge into decision-making and therefore power. So the argument is that the key to this decision-making is no longer going to be with humans. Now we can wake up from this imaginary future and ask, how far are we from that today? Are we going in that direction or not? And if so, what we need to do? So let's look at, in some ways, where this really began. It began sometime in 1950, well, actually a few years before that. But in 1950, Alan Turing wrote a paper asking, can machines think? And he then, this paper there's another paper, a subsequent one on, say, computing, machinery, and intelligence. And he asked amongst those, for example, who are watching this, is there someone who's actually a machine? And if so, how would you identify that machine? And that was the Turing test. And you can ask, what is it that we need to do to make a machine as intelligent as a human? And then one can go on and ask, in your Turing test, would you ask simple questions to identify this machine? What are the kinds of complex tests where the machine is more likely to fail? For example, if you ask the machine to play chess, it might succeed like a human. But if you ask the machine to compose a poem, it might fail, right? So those are the kinds of discussions which went on for a long time. So basically, there would be two kinds of approaches we take to dealing with machines, what is called narrow artificial intelligence or weak artificial intelligence. And that would operate in a limited context, but do it really well. So for example, if you want to program a drone to learn from all the data it observes, for example, look at all the foliage and then collect the data and transmit that data or have an internal ways of computing on that data and deciding what to do in terms of let's say, a farmer's decision about pests or not. You could imagine a drone or a set of drones linked to a computer doing that better and better and doing it much better than any human. That would be narrow AI. But narrow AI, therefore, is all around us. And you could see that when you do your Google search, or whether you have self-driving cars, or whether you have a computer beating someone in chess and so on. This would be called narrow AI. But a consequence of the effective presence of narrow AI is machine learning and deep learning. And machine learning and deep learning are forms of artificial intelligence, which you can apply so that you can have better and better narrow AI. And that's something which is very common, or increasingly becoming common. But can you ever have artificial general intelligence? Can you make a computer which is as good, as effective as a human, whether for defense or societal needs or the economy? And there are two broad views on this, that artificial general intelligence is something which will happen and come upon us very soon. And the other is that it's impossible. There's something really special about humans, and no machine can easily, or no sets of machines can easily mimic that. So what is that distinction? Is that likely? And we just need to look at biological examples to decide which of these directions we want to take. If you look at biological circuits, neural circuits, there are simple ones which sense and respond to environment stimuli. Layered on these are more and more of these circuits and more complexity of circuits, larger numbers of elements in the circuits, higher computational power, better and better response times in some cases. And therefore, these layered neural circuits can actually result over time in artificial general intelligence of the kind we see in humans. Now, human artificial general intelligence has come about not just by the physical structure of these circuits, but layered on that are important two other aspects, our cultural evolution and our language. So the power comes not just from the anatomy of the circuit, but by the software which over evolutionary time, or cultural evolution, we have layered on this. So it's important to keep in mind about how general intelligence has arisen. It's arisen by units which have been built up, but layered on these units at some point came extraordinarily unique software, which was possible only because of the complexity of the circuit, but then transcended the limitations of that anatomy alone. Now, in other words, if you forget about the details of the biology and the mechanisms by which neural circuits function and so on, in theory, some people might argue that human-designed circuits and computational devices can eventually get general intelligence if only it had the capacity both of speed and memory and able to handle multiple data inputs in the manner in which a human brain does. That's something which theoretically some people would argue is feasible, and therefore artificial general intelligence can come about as a consequence of tightly linked multiple units of weak AI. If that is so, then the time is not perhaps far away when general intelligence would be pervasive, whether in defense or the economy or in society and so on and so forth. Now, it's important to keep in mind that this is a consequence, but not only a consequence of data. Data is necessary, but data is not information, right? Data needs to be processed into a form which has information. Our brains do that dramatically well through a consequence of both the anatomy, which is developed in evolutionary time, and our cultural learning. Machines do that in much more cumbersome ways. Data sometimes has to be well annotated for them to handle, to be converted to information. That information needs to be converted to knowledge. So data is not information. Information is not knowledge. So we have to extract knowledge from information. That requires learning. That requires prior experience and analysis. And knowledge is not understanding. There are many conceptual leaps which humans make in converting knowledge to understanding, which links to unrelated experiences they have as individuals or as a society or societal memory. So the chain from data to understanding is extremely complicated, and so far has largely relied on humans being an essential component. Human hypothesis, therefore, drives both the analysis of data and the creation of data, such as in Large Hadron Collider, for example, to look at atomic physics in a variety, particle physics in a variety of ways, or we create data by looking at transport or health or agriculture and so on. So these are extraordinary components which we have. So intelligence is something which machines increasingly have. They have weak AI, and when applied to any kind of machine, whether it's drones or submarines or aircraft, can allow specific tasks to be done well. But for general tasks to be done well, so far, human interventions are very, very important. So what are the key questions? I'd like to end this, and we can go on to questions. What are the key questions we can ask of data today? We ask what is its provenance. So we need to know the reliability of the data we collect, either by aerial surveys or remote sensing or by sensors on the ground. The provenance of data is very critical for decision making in whatever instruments we make. Then what is the correlation and what is causation? That requires a handling of data in ways which we need to program these machines, have right algorithms, right machine learning to distinguish between them. If you have, a large population eating dosas, it doesn't mean that everything they do is caused by eating dosas. It might correlate really well with eating dosas. How do you distinguish correlation and causation? In very high speed, short timeline requirements. And secondly, how does one help to take decisions from the understanding of data in a situation where at the edge, you need to take decisions very rapidly. You don't have time to go to the core and compute. Yet the core is where the information, the learning, and all the data is. So the core edge connectivity at speed for decision making, again, across all kinds of areas are very, very important. So technology has given us data across scales in a manner which was unforeseen a short time ago. But is more data better? History has told us that less is actually better for analysis, and the more can actually confuse us. But it's not sensible, nor easy, nor should we wish away the availability of data. So we need to have a deep understanding of what decisions we're trying to make, and combine that with the analysis of that. So that really is the biggest challenge for industry today, whether it's in the defense or health or agriculture and so on, combining the deep domain understanding, combining that with manufacturing, and integrating into this data analysis and decision-making at high speed. All this was theoretically feasible a short while ago, with extraordinary development in material science, in sensor technology, and in data analysis has transformed this into something which is eminently feasible. With the onset of 5G and future kinds of communication technologies, the needs to integrate these kinds of sensor technologies and decision-making at the local level with speedy data analysis at the core and feeding it back becomes all the more important. But it's an exciting possibility where work of this kind in defense can feed into the civilian sector enormously and vice versa. Thank you very much.
Thank you, Professor Raghavan. Now it is time for question and answers. I would request the team there, please help him with the questions.
The first question is,
why don't you choose a question together? I'm quite comfortable.
there is a question from Shubha Kulkarni. What are the areas where science academics ought to be advising the government today?
Well, this is a question about the science academies. In India, we have 3 major science academies, and we have an engineering academy too. I must say that the Indian National Academy of Engineering has been extraordinarily proactive in advising the government over the years in terms of formulating plans for materials research, for AI in various sectors, for civilian aircraft, for defense aircraft, they've been very good. Our other science academies need to do this a lot more. Science academies do it quite a lot in every sector, in the US, for example, and also in the UK.
There is a question from Ishwar Sagar. Sir, where to draw the line while contemplating manual versus academic system?
Or automatic systems.
Automatic system versus AI systems.
Yeah. Well, the system is as good as the information you have, whether it's manual or automatic. The problem with many manual systems today is that people naturally take decisions based on what they would call their hunch and not by the analysis of data objectively alone. And this is because of a deep way in which we have evolved as animals. We need to act very rapidly and take a decision. If you see something coiled on the ground, you don't actually do a deep analysis to decide whether it's a rope or a snake. You assume it's a snake and you take a decision fast and then worry about the analysis. A machine tends to analyze all possible data and then take an objective decision. And that objective decision can be as fast, but it's more likely to be correct. Now, it doesn't matter whether it's a rope or a snake if you run, but if you're taking a proactive measure about whether you're going to damage the rope or a snake, it can have interesting consequences if you take a wrong decision. So therefore, machine information at speed integrated into manual decision-making is very important and is the ideal or reasonably feasible ideal as of now. But it's a big challenge about how to keep this separate. There have been instances, for example, or at least supposed instances, where very high quality machine data has given counterintuitive calls for action, which human intervention has decided not to act on wisely. And there have been other instances where machine interventions have suggested something which human intentions have wrongly overlooked.
There is another question from Ishwar Sagar, which states, what about IT security while using AI systems?
Well, I think the previous question also was from Ishwar Sagar, so he's a serial suspect. But anyway, Ishwar, the question is about IT security in the case of pervasive data. Now remember one thing, that the level of privacy which we have seen somewhat at higher levels in the 20th century were unusual. Before that, right through human society, the levels of breach of security or the absence of privacy were much higher. And there were ways by which people encoded data to prevent security breaches in a variety of ways. The problem with big data analysis is the security systems themselves are more amenable to being breached because of the ability to crack various kinds of cryptography by methods which can sift through a variety of possibilities very rapidly. Now, for that, there are countermeasures. There are, backends which are required for almost every device which we use, and that needs to be, again, controlled by cryptography and by cybersecurity measures. So this is a constant battle. Those technologies are well known about what kind of security measures we have, and the technologies to breach them also are actively being used. So there is no easy solution to say that you'll have an unbreachable technology, because in developing that, there would be components which are weak. And there's a demand in the defense, for example, more so than in other areas, for actually having a high level of security. That's also there in banking and finance. So it's a challenge about employing these technologies while actually having security. So we have all over the world cybersecurity agencies of various sorts which are involved in this. There are global standards, global practices to look at elements which might try to breach it. There are also national issues, and there are national structures for that.
Next question is from Yogesh Mishra. the protocol for working with data needs to be standardized, where hardware and software needs to be in sync. Is government also working on these lines?
Now, this is actually a very, very important problem and a big challenge all through e-governance, for example, not just in defense and so on, combining security with portability of data. So what are the kinds of platforms you devise which allow you to do whatever you're most comfortable with, yet the data you generate and analyze can be looked at elsewhere. So there are very elegant platforms now globally available, which are open source, which allow communications and interoperability, and stacks of containers in various kinds of networks, which allow you to have interoperability no matter how you look at the data. So I would say for public use, these kinds of stacks which are open source really are becoming the norm, and therefore the way you put in data and the way you analyze it can become more and more feasible. This combined with a layer of security allows, with multiple layers of security, allows these methods to be used in any context.
There's a question from Kalpesh Gandhi. How would defense and the government establish, validate solutions which enable replacement of metal with engineering polymers for better functionality and lightweight properties?
I mean, this is a fascinating area. I mean, one of the key aspects of autonomous vehicles of various kinds, either which are flying or going underwater or on land, is material properties. If you want energy efficiencies, if you want these vehicles to carry significant loads, then they should be light. But their being light is the enemy of robustness. How do you combine robustness with their being light? Now, there's extraordinary advancement in technologies which are proprietary sometimes, or patented, or difficult to access in composites, for example, other lightweight materials of various kinds. But here too, very interestingly and fascinatingly, AI and machine learning is playing an important role. That is, you are now able to design a wide range of materials and test out their properties at scale, have learning algorithms which learn those properties and therefore give you some amount of prediction combined with deep material science in development of new materials. This is a very, very important area for academia startup collaboration, because this can be truly transformative. It's a really, really exciting question. Sure, a couple more.
Sharma.
Sure.
That's different. I think we'd like to prove how safe is our data in our country.
Sure. Which one?
Puneet Goyal's question.
There's a question from Puneet Goyal. How safe is the data of our country, as we are dependent on mostly US companies, and our data is already hands with other?
Does not, it says it is not affect our security.
Does it not affect our security
and
threat to our defense?
So in a broad aspect, globally, leave aside where the origin of the company is, many aspects of data analysis involve big corporations of various kinds. So that is a matter where that needs to be addressed. Now, Indian data laws now require the storage of data in the country, and that has actually become very effective and very valuable. And the analysis of the data at different levels can go out or not, depending on various kinds of aspects. Combined with that, the government has put in place extraordinary measures for collection and storage and analysis of data over here. And thirdly, there are measures already in place for some time now to look at data in the context of security. So to assume that there'll be corporate dictation of data across the spectrum may not be valid. Corporates are certainly powerful, but there are also other components which need to be looked at.
Bhumika, now.
Thank you, sir, for answering so many questions. I'm sure our participants are thrilled and have learned a lot. With this, I would like to remind our participants that there is a poll being flashed on your screen. Please do not forget to rate us on the quality of the webinar in this poll. With this, I again transfer to Brigadier Suresh for a few words before we conclude. Over to you, sir.
Today in this webinar, Professor VijayRaghavan has dwelled in detail about data, the information analysis and its use in the various sectors and in particular to defense. It was a very enlightening speech, webinar, and it was well participated by the participants as well. So it was a very knowledgeable session, and thank you, Professor VijayRaghavan, and the other participants as well.
Thank you, sir. Please note that this session is also available on the Digital India Learning YouTube channel. Please subscribe to the channel for more such videos. Before I end, I will give you a tour of the website, DefExpo website. So on your screen, you will be seeing, you are seeing the DefExpo website. There is a seminar section in front of you. Underneath the seminar section, there is a section for webinars. Please click on that. You have all the information regarding the upcoming webinars here, and also the biodatas of the speakers we have had. The webinar link section, when you click on this, a page with all the webinars information opens in front of you. You can have all the list of webinars and register in advance for all the webinars. Now, before we end, I take this opportunity to thank the leadership without whom this initiative wouldn't have been possible. Shri Subhash Chandra, Secretary, Defense Production. Shri Barun Mitra, Special Secretary, Defense Production. Dr. Amit Sahai, Joint Secretary, Personnel and Coordination. Mr. Abhishek Singh, President and Chief Executive Officer, National E-Governance Division, for providing such an encouraging and supporting environment to us. Captain Nagesh Jain, Brigadier K. Suresh Pillai, and Captain Roy Joseph from Department of Defense Production. Last but not the least, NEGD Digital India LMS team for making this webinar a huge success. Do not forget to log in for our next webinar day after tomorrow, that is on 15 January 2020. The best question winner would be announced on 15 for today's webinar. With this, now we conclude for today. I hope you had an enjoyable session. Happy learning. Jai Hind.
Thank you very much.